Good day, sir. I am the Cadet Gonzalez Romel Jr. And for today's video, I am going to demonstrate a manual plotting. So here is the problem. Your ship course is 080 degrees through at a speed of 18 knots. At 10:15 the lookout reported a ship bearing which has the distance of 020 degrees through at a distance of 9 nautical miles. The same ship was seen after 6 minutes on the bearing at 021 degrees at a distance of 8 nautical miles. So in this problem, we are tasked to find the following, which are the DRM, SRM, CPA, BCPA, TCPA, true course, and lastly, the true speed. So the first step is to plot our ship on course, which has which is 80 degrees through and the speed of 80 nautical miles. So again, what 80 to 80 to 80 knots. So and the second step is to plot the first and second observation at a second observation. So at our first observation, we have a bearing of 20 degrees through at a distance of 9 nautical miles. So, and by using the 1 is to 1 scale, we can determine that our first observation is here. So, let's plot here. Next is to find our second observation which has a bearing of 021 degrees through and a distance of 8 nautical miles. So again, by using the 1 is to 1 scale, we can determine that our second observation is here. Then put a line here. This is R, R, and L. And I forgot. These are first observation, M1 and M2. So the next step is to transfer the RML line to the center in order to get our DRM. So gonna use this. So get your pencil or ball pen here. So now here is our DRM, which is 188 degrees truth. Okay, 188 degrees truth. And then the next step is to get our CPA. In order to get our CPA, we must use our triangular ruler, which has a 90 degrees perpendicular to its RML line. So here, 90 degrees. So here is the perpendicular 90 degrees of the RML line. So here 90 degrees. Okay. So this is our PCPA, which has a BCPA, which has a 90 degrees flip. So the next step is in order to find or determine the distance of our CPA, we need to use a compass divider, and by using the 1:1 scale, we can determine that our distance is, so here, center to the CPA, and so our CPA is 1.9 nautical miles. So our CPA is 1.9 nm. So the next step is to transfer our true course to here, M1. So our true course, so here. But the problem here is that we have no distance. So in order to find our distance, we must use the formula of d is equals to speed times the time. So here, where's my ball pen? So here, d is equals to s times t. So our speed is 18 knots, and the time and 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 the time is 6 minutes, which is the time difference of our first and second observation. So 6 18 times 6 is equals to 108. In order to get our time, the time, we must divide it by 60. So 108 is divided by 60. So the time is 1.8. So you use the compass divider, locate the 1.8 here, 1.8 here. So here, so this is, so here, now this is the distance of our E, which is 1.8 nautical miles, and the next step is to connect the E to the M2. So using the ruler. So the next step is to transfer so we need to transfer this line to the center in order to get the true course of the target. So here, wait. So here we have the true course of 119. So TC is 119. So one bullpen. One and our BCPA, I forgot. So the next step is to measure the M1 to M2 in order to get our SRM. So measure this from M1 to M2. This, then, so we have a 1 nautical mile. So after this, in order to get our SRM, we will use this formula. Then here we are tasked to find the speed. So S is equals D over T. So our distance is here 1 nautical mile, and the time is 6 minutes. So 1 divided by 6 is 1.67 times 60. So I forgot times 60. So 1 divided by 6 times 60. So the speed of our SRM is 10 nautical mile. So here I'll put the SRM 10 nautical mile. So the next step, in order to find our true speed, we're going to measure from M2 to E. So here, and transfer this. So we have a 1 nautical mile. So in order to find the true speed, we will use again this formula. So in this problem, we are assigned to find the speed. So same formula as this, S D T. So distance is 1.9 nm over time 6 minutes times 60. So 1.9 divided by 6 times 60. So we have our true speed has a 19 knots. Then put here 19 knots. And lastly, to find our TCPA, we need to measure from M2 to our CPA. So here, then transfer this here. So we have the distance of 7.9 nautical miles, 7.9 nm. So in order to get the TCPA, we will use again this formula. So this problem, we are assigned to find the time. So this T is equal to D over S. So substitute 7.9 nm is divided by the speed. Our speed is 10 nautical miles, 10 knots or 10 nautical miles. And multiply it by 60. So calculate 7.9 divided by 10 times 60. So we have computed 47, so 0047, and add this to the second to the time of the second observation, which is 10:21. So add this, we will come up to the answer of 1108 hours. So here this is our TCPA 110800.